This
Record.
conference will now be recorded.
There we go. We're confirmed. So, hello everybody. Welcome to the Cube Corner Show. I have a fantastic special guest here today, Sergio Mendes, and I'll tell you why he's fantastic. Because when I started learning Kubernetes, I went through the Kubernetes the hard way by Kesley Hightower. I went K8S, and it was tough. It was a learning curve. And then I came upon a distribution which made it a lot easier, especially to get fast clusters, K3S. And of course, I'm old school. I like books. I like to get a book. I like to write in it and do things like that, have notes. And I looked for a book and I came upon this. Okay, look at that. And then look, it's not one of these little thin paperbacks. This is a big book. Okay. And the author of this book we have here today. So Sergio Mendes, and look, I even got a signed copy. So authentic. And so Sergio's here. He's written a book. He's basically, his background in DevOps is huge. I'm going to let him introduce himself now and tell us about himself. But we will also talk about the book too and some things in there. So hello, Sergio, welcome, and tell us a bit about yourself.
Hey, it's so nice to be here this morning. Well, this morning for me, for Guatemala, in this recording. Well, about me, I am a systems engineer. Well, I move a lot in the cloud native ecosystem in general. Right now, I am a CNCF ambassador, but I love my community here in Guatemala, Cloud Native Guatemala. Currently working as a DevOps engineer and experimenting a lot with edge computing stuff. That's the reason to write a book. Playing a little bit with my students with these technologies, kind of, let's say, independent, doing research art development about cloud native technologies, maybe. So that's me in general.
So when did you get the idea to write the book? So first of all, actually, before that, how did you start off in IT? I always ask people that because it's crazy. Some people started off driving taxis. Other people like me were doing languages, and then we all ended up for some reason doing IT. Probably as we have to feed ourselves. But how did you start in IT?
In IT, that's pretty nice question. Because let's say that I wanted to be being a graphic designer, because I love to drawings and that things. I remember that in some years here in Guatemala were like some Marvel cards that you exchange when collecting some stuff at the supermarket and that kind of things. So I started to draw that kind of stuff. I don't have a drawing. I remember that I have a drawing there, but what's the reason? Well, I was starting thinking about to being a graphic designer. Then let me remember. Well, I was like trying this stuff, but I discovered that working drawing was not a thing that I will join. Well, I discovered that for me, work drawing was only my job, let's say. No, sorry, was only my hobby. So I was like, why work doing stuff with my hobbies? I was like, no, I don't like that. So I was like trying to discover another things. Then in the high school, let's say, I discovered programming, and I discovered that I was like enjoying programming, and I was like, if somebody pushed me to programming, there's not big deal for me. So I discovered that, okay, let's try programming for the future and get a job about that. And the bad part about it was like I stopped drawing in that moment.
Oh,
yeah, I was like, I stopped with my hobby. And well, but let's say that currently in the last 5 years, I not retaking the drawing, well, more or less, I discovered that I can apply it. Well, let's say that drawing, you need to have this kind of abstraction skill, more or less, to create the same like programming, but apply it to art, let's say. So I discovered that trying to apply that abstraction to photography I can
Oh,
make art too. So I started to took pictures and photos and that things. I do a little bit of photo cosplay, the people that do cosplay and use customs and that kind of stuff. Um, so I started with that. So
that's wild. And so, hey, can I
yeah,
ask you one question? Because I know a lot of IT people don't like drawing diagrams, right? So we try to copy them over. But since you're a graphic artist, maybe that's your super skill is actually doing IT diagrams.
yeah. Let me see. Let me.
Oh,
Well,
you'll give us an example too. Oh, this one. I'll
yeah.
have to
I
ask you
think
for the
that I
grade.
have. Ah, okay. This one, like, for example, the last time I was like, well, let's say based on someone that I know, I was like, why not to try to draw something? But let's say that something that I didn't mention, I am also a professor in the university.
Wow.
And let me show you. Here I have something. Let me see if I can find it. This is here is it. This is a little bit improvised, but yeah. Let me see. Just let me focus this again. Okay.
Now, that is so cool. Kubernetes food
Yeah.
store.
Yeah, I have like a tablet,
Oh,
but
okay.
I use this tablet to give my classes in the university.
Oh, wow. Wow.
So I say, okay, I have the tablet to create diagrams in my classes. Why not to try draw something? And in my classes, I started to do this kind of drawings. So let's
Oh,
say that this kind of drawings I use it in the university. So
well, that's
I
excellent.
was like, yeah, I was like, okay, let's start creating something that I used to do in my classes and be public to the people in the ecosystem. So this is pretty similar that the things that I do in the blackboards in the university, and maybe for somebody, no, you are copying the idea or somebody or something. No, that's like the general drawings that I used to do in the university. So
Well,
I
it's good
am,
too because people complain about the fact that Kubernetes is so difficult. And what I found is that if you simplify things at an abstraction level, then when you go deeper, it's much easier. So this is perfect. You know, this especially food too, because I like to eat. So you know,
yeah, for example, well, in this, taking this as an example, I explained like the oven is like the worker node, let's say.
mhm.
And when you put the eggs or the food where you are cooking are more like the pots or that kind
Oh,
of things.
fantastic.
So the different food is has some task or something to do in specific, like different kind of foods.
You know
And the
what? I
chef,
think we need
yeah,
a real demonstration. I mean, I kind of think that, you know, for this to really, we'd have to actually get someone in the oven and cook, and then we'll have to taste and
yeah,
make sure that, you know, make sure the cluster works well, right?
yeah, it could be like nice. For example, in this example, the chef is the scheduler,
Yeah,
somebody that is still receiving the orders and that kind of things and taking decisions like the control plane.
yeah, that's
And
fantastic.
yeah, here, the table is the service. It's the only way to access the food, right? Yeah, and
And you
there
need
is
a
a
load
train.
balancer not to eat too much, or else you gain weight, right? Your resources, you can have minimal requests on this on the cluster. Yeah, I wish this
Yeah,
would work with my eating habits, but
yeah, I remember that in the practice I was talking with, well, with somebody from Brazil, and somebody said me that, oh, my dad understood right now Kubernetes because he understand the concept using food and this chef and that kind of thing. So I try to do this kind of stuff to be funny a little bit and to simplify the, well, I know Kubernetes is like really complex. So,
yeah.
and taking back to the initial topic, like drawings and that kind of stuff. So I started to mixing this kind of soft skill, maybe art soft skill or something like that with technology and that kind of stuff. Maybe that's the reason that I love to do streaming. Well, right now we are in the influencers era, right?
Yeah, yeah.
But I really love to create content, not like pretty famous or something, I used to love taking pictures and record stuff. I also play the guitar.
Oh, wow.
And I think that I love arts in general, but I think that is a specific soft skill that an engineers used to have, like that abstraction and creation. Create music, create drawings, create photographies, create something, right? So
That's fantastic. So you're teaching, I guess, Kubernetes. Are you teaching programming as well at the university?
well, in the university, I am teaching operating systems.
Mm-hmm.
So I explained, for example, containers as a type of virtualization. Not
Mm-hmm.
I don't explain containers in the context of DevOps, let's say.
Mm-hmm.
And I use Kubernetes to explain distributed systems in
Mm-hmm.
some way. So I try to mix this kind of concepts in my course, just and be between these kind of limits of operating system, right? No
Mm-hmm.
outside. So that's my way to teach
No, that's
this kind of
wonderful.
stuff in the university.
Now you're also an ambassador, a cloud native ambassador for CNCF, if I'm not mistaken.
Yeah, yeah, right now. Well, I have to reapply. They have like 1 year for being an ambassador, so
So tell us about that. First of all, so you applied for it. Did you apply after or before you wrote your book?
after.
After. I'm just thinking, maybe I need to write a book. And but so when you're cloud ambassador CNCF, it's pretty big. I know a lot of people apply for it. What do you do? What are your tasks? You automatically get to go to KubeCon.
Let's say that, well, you have to match some kind of, let's say, experience. Well, do you have to have some kind of experience and get involved in certain specific stuff? Like, for example, be project contributor,
Mm-hmm.
like contribute to Kubernetes of something. Some people contribute to Kubernetes documentation. In let's say me, I don't contribute. I am not a code contribute. I am a non-code contribute. And
Mm-hmm.
how that works? Because some people listen, I don't contribute to a project, but that how I can contribute. So I can contribute to speaking about CNCF projects. That's another like kind of requirement to be ambassador.
Mm-hmm.
Speak about CNCF projects, host a meetup, a community CNCF group, a meetup, um, speaking in sessions, be a Kubernetes community organizer, create content
Mm-hmm. Great diagrams.
around the CNCF projects, right?
Yeah.
So making videos, participating in speaking sessions, also create content is part of writing a book.
Yeah. I was gonna
So
say
I
you come
wrote a
up
book.
with
Yeah,
content.
yeah.
How
So
long
all
did
of that, yeah,
how long did it take you to write that book? Just out of interest.
yeah. It took me like 1 year and 7 months.
Wow. Wow.
That was
That's
a
great.
lot.
Well, we're gonna talk about the book later because that's a
Mhm.
whole chapter for a chapter, so to speak. But yeah, so you're a professor. So what else would you like to say about yourself apart from that? CNCF ambassador and professor at university.
What else? What else? What else? I love to go to the church.
Well, that's. Have you seen a lot of growth in Kubernetes in Latin America? Because I hear, for instance, that like in Asia it's taken off, in Europe it's really taken off. North America, it's weird because you don't see it really en masse. But then I'll talk to somebody who's working at a bank or someone who's working in government. They say, "Oh yeah, we've got it all over the place." So it seems that it hasn't kind of drifted down yet. It's still up in the big kind of organizations.
Yeah, I think that in Latin America is growing right now. Well, let's say I can take as an example Central America,
Mhm.
because in Central America, let's say that we are not countries with a big population, let's say.
Hmm.
So if you take all the people together around Central America, is the equivalent of maybe one country
Yeah. Yeah.
of people that can work on Kubernetes. So we are not like pretty representative in some way.
Hmm.
But for example, because of the COVID-19, the people started to work remotely. So in Central America, let's say that we are not too many people, but there are some prepared people that the people outside Central America are looking for.
Hmm.
So it started to appear more opportunities for people in Central America, in Guatemala in general, outside the city, of course.
Hmm.
And right now, CNCF is working to find these people around Latin America, and there are some groups that put together all these countries to work together, create content, create stuff, and the mission is like someday that KubeCon Latin America happens. So
Oh, wow. That'd be
yeah.
fantastic.
So
Yeah.
there, let's say that right now, some active countries are Guatemala, Salvador, Costa Rica. We already have some KCD event, Kubernetes Community Days last year. Mexico is active right now. Colombia, Argentina, and Chile is like right now active in
Hmm.
Latin America. So maybe I am missing some country, yes. But in general, we are like starting to move on this ecosystem, or at least to have representation in the community groups.
Hmm.
So I think that is, well, is more active than the last 2 years in general. So
Yeah, and
yeah.
COVID, as you said, helped. I mean, there were some benefits to the pandemic, and one
Mhm,
was it kind of expanded our worlds. So, what
mhm,
interests me as well is you're talking about Latin America, South America, and especially, for instance, the countries with, huge mountain ranges and all sorts of
mhm,
geographical challenges, and Canada's very big too. And
mhm,
K3S, especially edge computing, is perfect fit for these kind of environments. And so,
mhm.
we're going to talk about how you started to get into K3S, what you liked about it, and also how you found some incredible, interesting ways that you leverage K3S. And I just want to go out and buy a Raspberry Pi if my spouse will allow me, and just set this up in my backyard. But
Yeah, I think that K3S, let's say that talking more about me, I think that in one moment in my life, I was like thinking, okay, I want to be a scientist.
oh, wow, okay.
Maybe that was the reason to be a professor too. And maybe that's the reason that right now I am working with H technologies, maybe. So um, I think that K3S has this kind of funny stuff for me. uh, so I started, and that's funny because in the university we had like some course about electronics and that kind of stuff, and I was like pretty bad at that stuff. So it's funny that right now I am playing with the stuff that I didn't love it. I didn't be like good with that stuff. So, but right now I love it. I enjoy these things. So I found like the Raspberry Pis because a lot of people is like, oh, I have a Raspberry Pi, I do this stuff, and I was like, okay, I am in this ecosystem, but how I can play with the Raspberry Pi? So I was like, okay, some people is running Kubernetes in this kind of devices. Let's try it by myself, and I discovered, that's pretty nice. Okay, Kubernetes running in a Raspberry Pi. Wow, I was like. And the other thing is that, for example, here in Guatemala, we work a lot. If well, a lot of people work in agriculture and this kind of stuff. So I was like, there was a course in the university that was like creating something about domotics and smart houses and that kind of things,
Oh, wow.
smart agriculture or something, but something simpler, right? Like nothing too complicated. And I was like, that could be interesting to create something similar. And I was like, let's say my big experiment using this kind of stuff was like using a temperature and humidity sensor, the Raspberry Pi, and I was like, okay, and I discovered that K3s was like pretty nice for this kind of environments, right?
Mhm.
And K3s was like pretty simple to use and has like a pretty small footprint, doesn't use a lot of memory, and it's like pretty nice to run on a Raspberry Pi, right? Because Raspberry Pi are so popular. I
Yeah.
was like, okay, let's play with a Raspberry Pi.
And I'll just mention for the users, just in case they're not totally familiar with it, K3S is basically K8S, but the person who created K3S took out a lot of stuff that he thought
Ah,
was
yeah, that's
extra.
true.
And so just because the funny story is it annoyed him that there's all these extra bloated APIs,
Mhm,
whatever. So he took them all out. And in doing so, he created a perfect edge distribution because it's
mhm,
lightweight. You can run it on literally nothing. And so what
mhm,
I'm really interested in you describing how you have your sensors out in the fields, how they use this LoRa protocol yeah, this is fantastic. So give us a description of this. I'm certain we'll have users going and trying this.
Okay, I remember that. Okay, well, this is a three Raspberry Pis, a pretty cheap switch, some USB hub or something like that, some connections there. Um, so just like K3s like give you that power, but there are some challenges when you are playing with hardware and Kubernetes. Let's say that okay, Kubernetes is wait K3s. You should remove all the unnecessary stuff to run the things because when you are removing and doing less things, you are consuming less energy, right?
Yeah.
And in edge computing, at least for example, apply it to agriculture. Maybe you don't have like a power resource. Maybe you are going to use a solar panel, so the energy consumption will be important for this kind of scenario. Um, so some of the challenges of just K-Trace on a Raspberry Pis should be, for example, as you mentioned, like you remove it. Well, the creators of K3s removed all the unnecessary stuff. One of that kind of stuff is the load balancer. And let's
Yeah.
say if you want to use a load balancer on K3s, you should, let's say, not simulate, but let's call it simulate this feature that you usually find in cloud providers.
Hmm.
So, for example, you should use some network software to simulate this load balancer, like Metal LB is one of those.
Yeah.
I don't remember the other ELB or something like that
Oh, the
that
service
people.
LB one. There's one that I
Yes.
think, but it's very primitive. It works, I think, for single node clusters. Service LB, I
Mhm.
think it used to be called something else, and I can't remember. And then now they've service LB, but it only really works on if you
Yeah,
have
there
one.
are like some projects around that, and that's one of the challenge. For example, well, let's say that you can buy a Raspberry Pi or an Orange Pi, or there are similar products to do this kind of stuff. You should buy, depending on what you want to do, create a rack, a small rack like that.
Hmm.
This is a small tower of Raspberry Pis, pretty cheap. I don't know, $16 or something like that. A Raspberry Pi maybe between 50 and 100. It
Hmm.
depends on your country too.
Yeah.
Um, a small switch. You can also use your smartphone as a router. I used to use my smartphone as a router for the Raspberry Pis.
Wow.
Uh, Another challenge for the Raspberry Pis running K3s is like you should, well, depending on how you are configuring this, you should have internet connection, but there is a special installation for K3s using the air gap feature to have all the stuff locally because the images that K3s is going to download and that kind of stuff. But it's a different story.
Mm-hmm.
But yeah, with a pretty low budget, you can build like small solution. The blue part in the left side, you can see the humidity and temperature sensor, the
Okay.
PH11,
Mm-hmm.
or something like
So
that.
these would
Maybe I
be out in
confused.
the field, basically. They'd be out in the field somewhere. And I guess the other interesting question I have is, so they're using solar panels. Um, they must use very minimal amount of energy as well, right? Because you don't want them turning off.
Yeah, I think that, well, maybe 2 weeks ago, I was like trying to buy a solar panel that is more or less like this size.
Mm-hmm.
So pretty, not too expensive. And you can also use it like a battery bank and the solar panel to power this Raspberry Pi, right? Well, in this case, for a solar panel, you should use only one Raspberry Pi, right? A single node cluster, right?
Mm-hmm. Mm-hmm.
So they are like pretty well. This photo was when I presenting. Let me remember. Well, an example to measure temperature and humidity in Tampa. So this
Oh,
photo was I was like testing the stuff in the Airbnb. So I took the picture there. Yeah, but I
wow.
discovered that, for example, let me remember. Yeah, that was in Cibo Navigate Tampa, and I went to Cibo Navigate London. In London, I had a problem because let's say I use my configuration using internet connection, but in the my session was in a room that was like um I don't know, maybe the building doesn't have like the maybe the connection doesn't enter there. Yeah, um so I have some problems, and for example, I was prepared for just my internet connection, and oh my god, what I can do
It's not working. Yeah. So
is
you had
not
to you had to,
working.
you had to pretend it was working, right?
Yeah. Or sometimes the internet connection is too slow. Somebody mentioned me like other kind of solutions. So then I discovered that for live demos, maybe I should record a video just in case.
Yeah, that's
And also, if somebody is like asking them themselves, like, do you have problems taking this stuff in your luggage in the airport? The
yeah.
answer is
I was gonna
no.
say that looks a little suspicious, you know. I mean, you say no,
Yeah,
it's
yeah,
based on Kubernetes. I don't know if the customs and border people would, they'd like that argument.
yeah. I was like, well, the first time I was like, maybe they are going to pick me my Raspberry Pi. So yeah, so suspicious, but no. In the airport, it's like, okay, yeah,
There's more people out there using Raspberry Pis and K3s than we think. So the border, no.
really.
So tell me, how does the system work? So basically, you're talking about having sensors, humidity sensors, and temperature sensors for agriculture purposes, right?
Mhm.
So give us a description of how this works, and what's involved, what pieces.
Okay. Well, for example, in my book, I describe 4 layers. Um, the cloud layer, near edge, far edge, tiny edge, based in a lot of commentaries around different books and everything is like the summary of the different layers that maybe you can use to create your edge computing system. So how is distributed all this stuff, right? Um, let's begin with the tiny edge, right? In the tiny edge, you are going to find the sensors, let's say the IoT part. maybe this blue sensor, right?
Right. So
The
the
blue
blue sensor.
sensor.
So this is not a Kubernetes cluster. This is just a device, right?
Yeah, just the blue one, right? This
Hmm.
pretty small, like this size. No, I don't have it here. Yeah. This part, the sensors are in the tiny edge. So maybe there is a device, or maybe it's an Arduino or an SP32 device that is taking or recollecting data.
Hmm.
And maybe this data is going to send to a K3s cluster, right? This K3s cluster will be inside the far edge. Well, let's say that is the far edge. Inside the far edge, you are going to find the tiny edge where the
Gotcha.
sensors are located. So in the
So you're
far edge,
separating pieces. This is interesting because I always thought of the edge before thinking, well, there's the edge and there's not the edge. But it turns out there are different pieces of it. And it's logically correct because if you have a failure with your sensor, that's not a failure with the K3s cluster. So it's a different piece.
it's a different piece, right? So the edge, well, or edge computing refers that you are processing the data near to the source. That's edge computing means. So this sensor is going to send, well, to send the information to a cluster in the far edge.
Hmm.
Maybe you are going to send this information to the cloud. Maybe. Could be
Hmm.
the public cloud or a private cloud. So the near edge should be like your router
Hmm.
using your smartphone or some internet connection or something. There you are going to find the near edge, right? In the context of telcos, you are going to find there the 5G network, 4G, towers, and that kind of stuff
Hmm.
in order to send the information to the internet, right? And in the cloud layer, you are going to find, for example, if this guy is going to send information about weather and that kind of stuff, and maybe you can see this information around the world, you have to send the information to a database in some data center of some cloud provider, and maybe you are going to put some Grafana dashboard in
Hmm.
that cloud provider in order that different people around the world can access this
Visualize.
Grafana dashboard. Yes.
Yeah.
So this is how it's distributed in general.
So it's interesting. So what you've got basically is you've got the tiny edge, which is the device. Then you've
Mhm.
got the local cluster. And I imagine that one of the reasons you have that is because you are assuming that sometimes you may lose connectivity. Is that one of the assumptions between the far edge and the cloud layer? And so that is an autonomous system over there, the far edge and tiny edge. They're always working. They don't depend
Mhm.
on the other
Mhm.
side of the equation. Okay.
Mhm.
And then when your connectivity comes up, or if you're, I guess, polling, or I don't know what system you're using, the data is transferred over to the cloud layer where you have some kind of a database. Now, would this be a Redis database, like one of those NoSQL types, or can it be any database?
Yeah, let's say that should be like, or you can use some databases and some protocols too. For
Mm-hmm.
example, this MQTT protocol is like pretty lightweight to send information. And some databases that I found that are like pretty popular and pretty easy to use, let's say, should be like, for example, Redis as a key value database. Of course, if you want to do something about using key values, a documental database like MongoDB,
Mm-hmm.
pretty easy to use.
Yeah.
Postgres is a database that in for this kind of stuff the people use a lot. Postgres.
Oh, really? Okay. Yeah.
Yeah. It's like I was like, okay, that's nice. MySQL is pretty popular. You can use also MySQL. I think that for somebody that is starting, MySQL is okay.
Mm-hmm.
That's a relation,
Yeah.
this kind
Relational
of,
database. Yeah.
yeah, relational database.
Yeah.
Maybe another one that is pretty interesting is like a graph database like Neo4j.
Oh,
It's
okay.
like pretty interesting. I found like, okay, this is an interesting database that also you can use. And time series database like Prometheus.
Prometheus, yeah, I was going to say, yeah.
Yeah. So
Because Prometheus, it's so easy. Well, I wouldn't say so easy. I did the exam, it wasn't easy, but to connect it to Grafana, and then you can have the easy visualization. So if I'm correct, one of the key elements of this is lightweightness is what you're looking for, right? Because of
mhm,
all the components and the distances and that, right? So you're going to be choosing your components. One of the major factors is going to be on whether or not it's heavy or not.
mhm.
Okay.
So yeah, for example, there are some kind of maybe not K3S distribution, but some projects around K3S like CubeH. CubeH, as I remember, let's say that is an Asian project for
Hmm.
from CNCF. So they solve some problems that you used to have on edge computing environments.
Oh,
So
okay.
if you lose internet connection and that kind of stuff, for example, they have like a master node that is the K3S, but the worker nodes just need to have a Docker installed
Oh, really?
and roll
Wow.
and some diamonds, and it's like a little bit pretty interesting. So
That's wow.
I,
That you're minimizing even more there, right?
yeah, even more, I was like interesting, and I also saw some videos on the internet about how they are using QH to monitoring breaches,
Oh, wow.
how to monitoring drones.
Oh, that
That's
must be
pretty cool
fascinating.
stuff. In yeah.
That's something I didn't think of, drones, because so what I like about this is this framework that you've got could be applied to anything. I mean, you're using it for sensors for humidity and temperature, but what you've got there, you could put that in drones and I guess have video if we went really crazy. I mean, you need good connection. But that is fantastic. So are you seeing a lot of this type of thing being implemented in agriculture, in government, for instance, to look, over, I don't know, seawater, stuff like that. And I can see this especially in the natural areas. Like we have a lot of wetlands in Canada, and one of the things the government
Mhm.
likes to do is to watch the wetlands, to look at the level of the water and migration of birds and things. And theoretically, you could take this and put these sensors all over the wetlands. So you're seeing a lot of demand for this?
Yeah, I think that well, let me choose some histories.
Okay.
For example, I have here that in Brazil they want to create a kind of let's say edge network to share data across the city. So let's say that big edge network, like using like thousands of devices, right, on each block in the city. Um, what else? Well, these use cases of Asia, I think that in Asia they are using a lot of edge stuff and using robots and that kind of things.
Mm-hmm.
They
Oh, of
are
course.
pretty advanced on this kind of stuff. That's the reason that there is a break from China, the Cube H.
Mm-hmm.
What else? In I think that I have this challenge because here in my country we work a lot in agriculture. So I am trying to create some kind of or experimenting soon some use cases. There is like some use case that we are working as a thesis with a student right now to
Mm-hmm.
monitoring a river.
Oh, wow. A river.
Yeah,
Oh, that's
a
fascinating.
river, yes. Because we have a lot of rivers here, so the pH of the river, and there are like some metrics that you can measure of a river about how is the water, is acid or something like that, using like small sensors and sending. There's a pretty interesting protocol to send information using low energy that is called LoRa.
Oh yeah, I was going to
Like,
ask about that. It's in your book, and
yeah, it's in my book.
your book was a real discovery because I'd open a new chapter and say using LoRa, and I go, I've never heard of that, and I look and it, wow, you know. So describe
Yeah,
that.
and let's say that the book is like pretty theoretic stuff.
Hmm.
Maybe some people can say, "No, you don't have experience on this." It's more like a research, let's say,
Hmm.
about the trends of edge computing and Kubernetes stuff. But I discovered that this LoRa, and then I confirmed that LoRa is used a lot around the world. So this LoRa stuff is like a kind of Wi-Fi, well, a kind of Wi-Fi protocol based in, not the specific Wi-Fi, but something similar
Hmm.
that can give you the power to send information between 2 and 10 kilometers.
Wow. So it's
And the
low energy.
device
You
just
don't need
need
a
to
powerful
use,
transmitter, right? That's what you're saying. Yeah.
yeah, but you can send a lot of information.
Hmm.
Yeah, it's like more like radio signal stuff, and you can use like 1.5 volts battery to send information using this device.
Wow, that is incredible. Yeah. So that's
Yeah.
the other thing I point out here is one of the beauties of Kubernetes and especially K3S is the low cost because, you know, maybe 20 years ago, 30 years ago, similar projects could be done,
Mhm,
but using a lot bigger pieces of technology and more importantly, a lot more expensive technology.
mhm. Yeah, so this kind of stuff is like the LoRa can give you that power to send a lot of info, well, to send information in a pretty long distances. I also tested this kind of stuff, like let's say that here in my house, and I was starting to walk like maybe 1 kilometer, and I remember that, well, you have to have like two devices, the one that sends information and the other that receives information, right? So also you can connect this LoRa. Let's say that right now the ESP32 devices that is more or less like an Arduino
Hmm.
includes like some small devices that includes LoRa and Wi-Fi together, right?
Oh, okay.
So you can receive the LoRa information, and then you can connect to the Wi-Fi to send information to a
So
cluster,
you can
right?
then send it. Oh, so it's like a little, yeah, a little, that's fantastic. Wow.
Yeah.
I guess the lore would be really important if you're talking about locations, you know, which are really isolated. So mountain locations or areas where there's no cell phone towers. That's where you would deploy the lore
Mhm.
technology to get you closer to, you know, regular Wi-Fi or cellular, I guess.
Yeah. So for example, returning to the thing that you were asking, like how this will apply to my country, you can send this lot of stuff in a big farms, big places to send information about the weather,
Hmm.
monitoring rivers. That's another use case. Also using the sensors of this kind of stuff to prepare the food. I was like, let me see. Ah,
Hmm.
yeah, this is the other stuff. This is our application. Like the the agriculture. Well,
Hmm.
let's say that food techs cover. This is something new that I am exploring. Food tech covers like farming, processing, and distributing food, right?
Hmm.
So the agriculture is like the first step, right? So there, for Latin America countries, there are a lot of use cases that you can apply for food tech using K3S or edge computing, right? So that can summarize everything when in Latin America, well, Mexico, Guatemala.
Hmm.
Well, a lot of people know that Guatemala has like like good coffee, and
Yeah, yeah.
I know that, let's say that here there are like big farms that they look for the coffee, and they use drones to do
We're doing.
irrigation and that kind of thing. So they do a lot of image analysis to use the drones for irrigation, fertilization, and that
So
kind of
using the
stuff.
drones, they can see what areas of the crops are dry, and then they can pinpoint. So that's wonderful too when you think about it, because in the past you would just watered the whole field and you're wasting tons of resources. Whereas now you're saying you
Mhm.
can use the drones, edge technology, and then you don't have to, okay, this part of the field needs it, that part doesn't. I mean, it's
Mhm.
fantastic. Yeah. And I saw you had another diagram there. Was that the diagram of the food tech? Apart from it was before the chicken. Oh yeah, this is interesting. Yeah.
Ah, yeah, more or less. I have it another one that there is a corn there, and but there is not here. Yeah, so yeah, this is like right now I am working on some food tech stuff, but it's like cooking scrambled eggs with some stuff and everything. But they are also for that kind of scenarios, they're pretty complicated because you have like, well, some of the complications will be like the heat that
Mm,
can destroy your pieces of your hardware and that kind of stuff, how to measure that. I also discovered, let's say that in Brazil, I was like talking about this and I said, okay, I discovered that in this kind of scenarios for cooking food, cooking in specific,
mhm.
they use a lot of thermal cameras. And I was like, that's pretty interesting, but I didn't know it why. And somebody that was working on food tech mentioned to me like they prefer to use thermal cameras because support more the heat and that kind of stuff and destroy less than a sensor
Right.
in
Yeah, I was gonna
terms
say,
of
because if you're using
yeah.
a sensor and it's too close to heat source, you could lose the sensor. And I never thought of thermal images. And so this is all being connected in information. Wow, that's fantastic. And I guess the advantage here too is you're going to be able to uh, produce more food. You won't need a human being there eventually. Of course,
Mhm.
then we might lose our jobs, but we'll be the ones programming. That's
Yeah, I think that I found in some commentary like this kind of stuff is like the third revolution. Well, the third revolution in the world is like food tech, right?
yeah,
And the stuff is like optimize the process,
yeah,
optimize the food and the ingredients. So if you optimize that using less water and that kind of stuff, you are like producing optimized people, right?
yeah, yeah. And,
In
and
in
also, we also think too is that we're trying now in the world to conserve as much as possible because in the past humans were wasting resources, and this technology fits right in with that, and we can see it being used so many places. For instance, I was thinking also you could use this to monitor pollution, you know, a lot
yeah.
more effectively.
And this other stuff moves me like this topic that is like environmental sustainability. Just let's say have a better approach of use the energy. Um, what else? Less power, ERM devices, better for the environment, less carbon stuff and that kind of
Yeah,
things. And yeah, I think that's the thing that I'm working right now, how to use less energy. Also, for example, using Knative on K3S scenarios are like pretty nice because you are just processing the thing and then you kill the program and because you are killing the program or the pod, you are stop processing and because you are stop processing you are using less energy, right?
yeah, yeah. You don't need to have
So
a constantly working device. You can, yeah, turn it on. And I like this. This is obviously your graphic design course
no, no,
history.
no, no, no. This one is
Oh,
coming
oh, okay.
from the target sustainability for CNCF. Yeah. So yeah, that's something that well in CNCF they are exploring this kind of stuff. They are looking more in the context of cloud computing in general,
Hmm.
but this has application to the thing that we are talking about: edge computing, food tech, agriculture. and all that kind of stuff of IoT. So it's like complementary. So environmental sustainability is a pretty big topic. So, but in general, it's something that I am exploring and mixing this with edge computing, right? So
Yeah. And the thing I'll mention here too, since I'm a data protection specialist, is that
oh,
all this incredible information we're collecting, we need to back it up. Obviously, that's one thing. Someone might set up a great system, and even though it's monitoring right now, we need to keep records historically, obviously, right? To compare like climate changes and whatnot. So you want to protect your data as well. I thought I'd mention that. I always mention data protection.
okay. I remember, well, when I was writing the book, I also, well, I created like some diagram that I mentioned, like how to protect the data, right?
Mhm.
Well, I remember that some people that say that well, the people fails to protect their data in the basic stuff, right?
Yeah.
Like use a certificate, encrypt your data, um, use a right password, user password, and
Yeah.
that kind of
Yeah.
stuff. So in my diagram, I also include like, well, there is a kind of canvas diagram that I
Hmm.
used to use that I explain, well, what things you have to cover to protect your data. In edge computing, it's like pretty similar, not like new stuff that you should do. So pretty basic certificates, encryption,
Yeah.
and user password,
Yeah. Yeah.
and private endpoints.
Yeah.
But
Well,
it's a
yeah, because
Kubernetes
when we
cluster,
think
right?
about it,
So
all this information, what people I think are realizing, or they realize after their first problem they've had, is that information is valuable and it can be used against us, right? So, for instance, just the fact that if someone could get control of your edge system so you stop getting the information and then blackmail you, for instance, like a ransomware situation, right? Let's say you've got a system set up. So that's very important. I'm glad you mentioned that. And also the fact that you don't want this data being transmitted openly over the wire, just in case you don't want people listening into it, right? And learning about it. But
yeah, the other stuff is like, well, you can do pretty interesting configurations, like, for example, well, but there's a challenge, right? Because the data could be processed locally, but the data could live in the cloud, right? So
yeah,
maybe you can install the device, but the data is not in the device, it's in the cloud, right? So
yeah, it's
I
being
think
pushed
that a
through.
big challenge, yeah, I think that a big challenge for security about edge devices and this kind of stuff, we will like, what if somebody stole the device? What
Well, yeah.
information is inside,
Or they
right?
manipulated the device. That's a good point. Like, what if, I mean, we're not talking maybe agriculture, but let's say the device is doing something different. It's really important. And someone manipulated the device, got into the device or affected the device, the sensor, and then putting false information in. So it's a whole new field. So I think we're going to have jobs for a long time because there's always going to be a challenge.
Yeah,
So
I
we have
think that
2 minutes left. What would you like to say in the last 2 minutes? A message to people or something else that you might have missed?
uh, about to the people, maybe that do what you love and
That's a
try
good one.
to be persistent. I think that the that in general is not luck, is that if you are persistent, if you are trying to get new skills, prepare yourself, study, work hard, and when the opportunity comes, it's going to be yours, right?
Yeah,
For
that's
me, it
perfect.
was like, let's say that talking about some years ago and where I am right now is because I was like working hard, right?
Yeah.
So
And doing what you
also,
love.
well,
Yeah.
yeah, there are opportunities and God helps you. So,
Yeah.
but you should be prepared, right? If you are not prepared, there's opportunity, but you can take it because you are not prepared, right?
You'll miss them. You'll miss them.
Yeah, maybe God can give you some grace in the interview, but
Yeah.
you should be prepared, right? So
And know and study your stuff. Well, so what I'd say on that as a finish, the
ah
book you need to study, right? And this is a perfect book. It's a fascinating topic. We could talk about this all day long. I mean, I pepper you with questions, But I really appreciate this, Sergio, and I hope, you know, we keep in touch, and I'm going to be watching your career. And if you bring out any new books, you know, you've got one person definitely going to buy it. So thank you very much. I really appreciate this. And folks, thanks for joining us, and we'll see you next time on the Kubernetes Corner. Thank you.
Thank you. Bye.